Hello everyone, we're on to paragraph 2, proposition and proof, and here we already get to the core of this chapter. What I will do is I will explain a few terms, proposition and proof mostly, and show an example of it afterwards. So let's just start with those terms. A proposition. A proposition is kind of what you would call an hypothesis in most of your other subjects, in science, in biology, physics, chemistry, something you think might be true. Something, let's say, a statement. So you usually would get to a proposition after having a few examples and seeing something happening the same way several times. But we'll see it in an example in a moment. So we start with a proposition, and in most subjects, in biology, in physics, in chemistry, what you would do then after you have an hypothesis is you would do an experiment to see if it is true. But in mathematics, we don't really do experiments. Instead, we create a proof, which is a logical reasoning. We're using rules you already know to show that the proposition is true. So we combine the rules we know, the rules that we've already learned about, and we see if we can use those rules to also get to our proposition. And once we have proven our proposition, we get to call it a theorem. So those rules we already know are actually theorems we already know. This is a very core concept in mathematics. Basically, all of mathematics is built up that way. We have a few base rules that are not provable and are just given, but after that, everything else is built up from those few rules by proving them so that we have a theorem, and from that theorem we can get more proofs, so more theorems, etc. All of mathematics is built up that way, and the first topic that was built up this way, all the way back in Greek times by Euclid, was geometry. So what we're doing in this chapter with those geometry rules, with those angles, is something that was done before Christ already in the books that Euclid wrote, and has been a topic of mathematics in high school for many years. So yeah, let's have a look at an example. We have learned already in year 1 that if we have a triangle, that the angles, oh, I don't need to write down the angle sign there, that the angles together make 180, but suppose we don't know that yet. But we've tried a couple of triangles, we measured them, and each time they do seem to add up to 180. So my proposition for any triangle, the three angles add up to 180 degrees. That's my proposition. I've tried a couple triangles, it seems true. Now I want to be sure that it is correct. And I have a couple rules that I can use. I know the straight angle, I know the full turn, I know the opposite angles, and I know F and Z angles from the previous paragraph. To actually prove these ones that I've just mentioned, some of them are quite difficult to fully prove. They get into some very difficult rules, so for now we'll just assume that they are true. And from that, I'm going to try to prove this. And for that, I'm going to draw an extra line. Well, let's actually I'll first draw this, because this is the line I'm going to use. And that means I need to number these. And what I want to get to in the end is that angle A plus angle B plus angle C, C2, equals 180 degrees. That is my goal. I want that to be true. And I need to combine my previous rules. Well, I've just drawn this line, and very specifically, I've drawn that as a parallel line here. And so there's a couple of things that I know. I know that if I combine the three angles at C, they make a straight line. So I do know that angle C1 plus angle C2 plus angle C3 make 180. And this is where it gets important to know those names, because to organize my proof, I do have to constantly write down what rule am I using. And here I'm using this straight angle. So it's important to write that down so it's easy to follow what steps I'm taking in my proof. I have a feeling I'm gonna need a little bit more space, so I'm moving that down a little bit. Okay, so I know this. But obviously that is not nearly what I'm looking at yet. There's some more things I know though, because I can make a Z angle here. So I know that C3 and angle B are also the same. And this time, I'm going to keep typing the rules. That is because of a Z angle. So what I can kind of do is here I can actually write down B. So I've got my C2, I've got B. All I need to do is get rid of this one. And that should somehow be equal to A. Well, if we check out another Z angle, that is true as well. I know that angle C1 is equal to angle A. And again, this is because of a Z angle. So again, I write down very structurally what rule I'm using. And by this point, I have been able to replace this. I can replace the A here. So I'm done, and I have my answer. Lastly, to finish my proof, I have to show I'm done. A simple way to do that is simply by putting a little square there. That's just a symbol that mathematicians use to say, my proof is done. If you want to go the historical, traditional way, then we don't do that. Instead, we use an abbreviation, QED, Quod erat demonstrandum. That is the traditional way of ending a proof. You don't need to remember what it means, but quod erat demonstrandum, that which is to be proven. So we have proven what we were supposed to prove, and we're done. One last important thing here to note is that I've used any random triangle. In a proof, I can't use a very specific triangle. If I would specifically use a right-angled triangle, then maybe I get a proof that only works for right-angled triangles, not for any triangle. If I use an isosceles triangle, maybe I get a proof that's only true for isosceles triangles. But I want it to be true for any triangle, so I have a triangle with no special properties. That's a little extra thing that you probably don't need to worry about too much just now, but I did want to already mention it. But yeah, this whole concept from proposition through proof to theorem is the basis of all of mathematics, and in the rest of the paragraph and in the rest of the chapter, we're going to practice that a lot more. And I think that's all I needed to say about this paragraph, so good luck practicing that.